Hi guys, so we're just going to continue the conversation today about solving systems of equations by elimination. I think you guys, or maybe you might kind of know where this is going considering how we spent the second day on solving systems of equations by substitution. Today we're going to talk about like the infinite solution versus no solution kind of thing. So this really shouldn't be that bad, I hope. Again, this stuff is coming from section 5.3 in the textbook, if anybody still goes in the textbook. But just a quick refresher on how we do stuff like this. The goal here, we still have that freedom of choice, right? You can pick whichever variable you want to eliminate, X or Y, it really doesn't matter. But the goal here for elimination is that we want the coefficient in front of that variable that we pick to have the same number but opposite signs. So when we look at this problem, I'm looking at the y's just because part of the process is already taken care of. We have one negative, one positive. So I think I'm going to go with y this time to eliminate. And we want these coefficients to be the same, right? So we're going to have to do a little bit of manipulating to make those coefficients the same by multiplying those numbers by certain things in order for them to become the same number. So how do we think about, well, what number do we want them to be? What number would be easiest to get via multiplication? And one of the ways you could think about that is the least common multiple of both of those numbers. What's the least common multiple of 2 and 9? That's the coefficient that we want in the end. The least common multiple of 2 and 9 is 18. So when we look at this first equation, we're thinking about what are we multiplying 2 by to get 18? And we're multiplying it by 9. What are we multiplying 9 by to get 18? We're going to multiply it by 2. All right, that's kind of the easiest way to figure out not necessarily the least common multiple of two numbers, but just any old multiple is you could just multiply those two numbers together. You'll probably get, or a lot of the times you might get some pretty large numbers, but it's pretty straightforward and works pretty much every single time if the idea of least common multiple is still kind of not the best, you know? So when we do all this, what do we get? We get 18x minus 18y equals negative 12, and 14x plus 18y equals 22. So this is what we want, right? The whole point of this is so that when we add up both of these equations, the negative 18y and the 18y cancel out. So what we're left with is 18 plus 14, which is 32. 32x equals... What's negative 12? $10? I messed up. This is not supposed to be negative 12. Negative 6 times 9 is negative 54. Whoopsies. So this should be negative 54 plus 22. There we go. That makes more sense. Negative 32. So now that we have one equation in one variable, we could easily solve this for x. Now when we divide both sides by 32, that gets us a lot nicer of a number. X is negative 1. So now we can take that negative 1 and plug it into either of our two original equations to figure out what y is. Again, it doesn't matter which one you plug x into. You should get the same thing regardless. I'm going to plug it into the first one just because, again, the numbers are a little smaller. 2 times negative 1, minus 2y is equal to negative 6. Negative 2, add 2, divide by negative 2, so y is 2. And then, last but not least, make sure you write your final answer, excuse me, as an ordered pair. All right? That's your quick refresher. So, let's see here. All right? when I'm looking at these pairs of numbers, we have 6 and 3 both times, right? 6 and 3 for the x's, 6 and 3 for the y's. The signs are the same for both as well, so we could really pick whatever we want, x or y, to eliminate. Doesn't matter again. We did y last time, so we'll go with x this time to eliminate. And what do we want that coefficient to be? What's the least common multiple of 3 and 6? Well, the least common multiple of 3 and 6 is actually 6. All right? So if we're trying to eliminate x and we have -6, we can leave that alone. So we're going to leave this first equation alone and then just work with multiplying the second equation. So we want, since this is -6, this has to be +6 in order for the x's to eliminate. So how are we going to get +6? -3 times what is going to be +6? Well, it's got to be a negative because negative times negative is positive. And in this case, it's going to be -2. So when we multiply all that, we get 6x minus 6y equals 6. I'm going to rewrite this first equation down here for the sake of organization. And what happens? Well, the x's eliminate like we wanted to, but -6y and 6y also cancels out. So the entire left side of the equation is gone. We're left with 0. And then when we do 6 minus 11, that's -5. So we're already starting to get into that territory of the weird things that happen. And I think you guys, hopefully by now, can make sense of at least what's going on after this. When is 0 ever equal to -5? It's not. So, because this is not possible, what are some possibilities for x and y to make this system true? There's nothing. So there would be no solution to this problem. Okay? This one's very, very similar. Again, we've got the same pair of numbers for both of the variables. The signs are also the same, so we'll just kind of go back and forth. We'll eliminate y this time. So what's the least common multiple of 4 and 8? It's 8. That's the least common multiple. So since this second equation already has +8, we're going to leave it alone. We want this coefficient on the y to not only be 8, but -8 in order for them to cancel. So 4 times what is going to get us -8? It's actually -2, again. So when you do all that multiplication, -8x minus 8y equals +8. And what ends up happening now? Well, we were trying to eliminate y, so that cancels. The x's also cancel, and so do the numbers. So we're not only left with 0 on the right, on the left, but we're also left with 0 on the right. 0 equals 0. And what does that mean? Is that true? That is actually a true statement. 0 does always equal 0. So again, it's one of those situations where all the variables cancel out. All right? The no solution infinite solution business only happens when every single one of your variables cancels out. If you get something like 0 equals 5, like we did last time, or 0 equals -5, that doesn't make any sense. It's not possible for 0 to be equal to -5. So that's why there's no solution. For something like this, where you get the same number on both sides of the equal sign, 0 does equal 0. If you got something like 5 equals 5, that does make sense, even though you're not used to seeing stuff like that. So my point is, this is an example of an infinite solutions type of problem. Okay? I think I'm going to skip this. Same kind of thing with like substitution. You might be able to pick up on some patterns the more you do these kinds of problems with infinite solution versus no solution on what the numbers end up looking like for it to be infinite versus no solution. I'm still going to be looking for the work for these kinds of problems on homework and stuff like that. So to me, this looks like it's going to be normal, so I'm going to skip it because we've done stuff like that already. And this looks like it's going to be slightly more interesting. I am going to do the last problem, off camera, and then you'll have the answer to it anyway. So This is actually interesting, or slightly different than the last couple problems we did, because again, for both x and y, the numbers are the pairs of numbers are pretty similar, and also we have both where one is negative, one is positive. So this might be slightly easier. I think we did y last time, so let's go with x to eliminate. The least common multiple of 2 and 4 is 4. Since this is negative, we're going to want this to be positive. So 2 times what is going to get us positive 4? Positive 2. So we have 4x minus 4y equals 16. I'm going to rewrite this. Negative 4x plus 4y is equal to negative 16. And once again, everything ends up canceling out. So you're left with 0 equals 0, which means there are infinitely many solutions to this problem. For this, let's go back to y, okay? The least common multiple of 3 and 6 is 6. This one already has a 6, so we're going to leave this alone. If this is negative 6, we want this to be positive 6, so 3 times what is positive 6? Again, that's going to be 2. 8x plus 6y equals 4. So the y's cancel. The x's cancel. And you can add up the 2 and the 4. That's not going to cancel out. You have 0 on the left and 6 on the right. So 0 equals 6 does not make any sense. There's no solution to this problem. And I think that's everything. Yep. So like I said, I'm going to do a couple examples ago. I'm going to do that later. You'll have the answer to it in case you were curious. Please still show all your work for these kinds of problems. Even though infinite and no solution is a lot simpler, I still want to see work so that you really understand why it's no solution and infinite solution, and still practicing all of the elimination stuff. And I think that's everything I have to say about that. So you guys know where to find me if you need any help. And I will talk to you guys soon.